Okay, hi everyone. So this video is for JC1 H2 Mathematics, and in this video we're going to go through all of the pop quiz solutions for pop quiz 11, 12, 13 and 14. Okay, so hopefully with this will help you to explain roughly the idea that we have for this pop quiz. Okay, so let's take a look at number 1 over here. Okay, so we're going to integrate this function. Okay, we're going to integrate this function over here. Now, so let's take a look. Before we start, right, let's check, especially for rational function, right, the main strategy is we need to check whether are there any relationships between the numerator and the denominator. Turns out, right, we have. So this one below is f. The f prime, right, by right should be 2x minus 4, right? So we already have the 2x over here, right? So it's definitely related. Okay, then what we're going to do is we're going to insert a minus 4 over here. So I'm going to put a minus 4 over here to include in so that I can form my ff prime. But at the same time, right, I will need to add back so that I can balance back the whole thing. Okay, so it means that I can split this whole thing to these two parts over here. Okay, the first one being the 2x minus 4. Okay, because this will form our ff prime. Now at the same time over here we have a 4 over the same denominator. Now for the 4, because it's a constant, right, what am I going to do in advance is I will just complete the square. So for this one over here, I will complete the square to something like this. You can work on the side, okay, but when I complete the square it should be something like this. Okay, so the next step would be we will need to integrate this, right? So how do we integrate this term? Now this one over here, even though it's ff prime, but the main form, right, is actually 1 over this, correct? 1 over something power 1. So how do we integrate something dx? It will be actually ln of this thing plus c. Okay, something like that, right? So that will be the main function over there. So it means that my answer for this one will be ln of x squared minus 4x minus 1, like that. Okay, with the modular sign. Now next, plus. Okay, then the next one over here, right, now the reason why I do this and the reason why I do this completing the square is because I can match it to one of the formula in our MF27. Okay, which is right up here. Now as you can see, we need to express in the difference between two squares, so hence we need to complete the square. And just applying this formula directly, so we will have something like 1, okay, so this is on top is 4, so 1 over 2a. The a over here is 5, root 5, so actually it will be 2 root 5. Okay, now ln of, now the numerator, so I have x minus 2 minus root 5 minus a. Then at the bottom would be the same x plus 8, like that. Okay, then because we've already integrated, so we will put a plus c. So with this, right, we will simplify the constant multiple to be like 2 root 5 over 5. Okay, so this is the way we will simplify question 1. Okay, so this is the end of question 1. So now let us continue with question 2. So making use of the substitution, find the exact value of the definite integral. So the thing about this definite integral is it will be very hard to just integrate like that directly. So we need to do a smart substitution. So over here, if x is given as tangent theta, to set up a bit, so dx d theta would be equals to secant square theta. Now in pencil, we're going to write dx is equals to secant square theta d theta, like that. Okay, so this is our part of our setup. Okay, next, we are also going to look for the value of theta. So for example, when x is equals to 1 over root 3, okay, this means that our tangent theta is equals to 1 over root 3. So this means theta would be tangent inverse of this, and tangent inverse of give us the angle of 30 degrees or pi over 6 radian. Okay, now in the same way, when x is equals to 1, so we have a tangent theta equals to 1. So theta over here would be 45 degrees, pi over 4. Okay, so this is how do we start this equation. Okay, so we have the limits to edit, the expression to edit, and the differential to edit. Okay, so let's start with this question formally. Okay, so this integral over here, now let's replace one shot. So square root 1 over root 3 I will replace with pi over 6. Okay, so everything must substitute, so pi over 6, one shot preferably. Next one over here, when x is 1, y is pi over 4. Okay, x squared on top would be a tangent square theta. At the bottom would be 1 plus tangent square theta square. And then the whole dx I can replace with whatever this is. So this would be a secant square d theta d theta. Okay, so let's do a little bit of trigo, right, in case you cannot remember. Okay, so this whole limit stays the same. Now I have tangent on top, but the one below is actually our secant square theta. Okay, and then we also have another secant square theta square. Yeah. Okay, so something like that. Okay, so we will end up with this situation over here. We have our tangent square theta over secant square theta d theta. Okay, so let's try to simplify a bit. So over here, right, tangent is equals to sine over cos. Whole thing divided by secant square. Okay, so this would be 1 over cos square. Something like that. So because the cos and the cos will cancel, so we actually have sine square of whatever argument that we have. Okay, so this means that okay, we will be integrating. So from the fraction, right, we can simplify it to sine square theta d theta, following the working over here. Okay, now then afterwards, what do we do next? Because this is a square, we'll do the double angle formula to convert. So this one over here, we convert to, okay, I have a half out here. Okay, and then when we convert, right, it will be convert to 1 minus cos 2 theta d theta. And then after that, I have a half on the outside, lambda minus half of, theta minus half of sine 2 theta, like that, from pi over 6 to pi over 4. Okay, so subbing in over here, I have half of, okay, or maybe I should just put the half in. So half of, okay, never mind, I just put this in then. Half of pi over 4 minus half sine pi over 2 minus pi over 6 minus 1 half sine pi over 3. Okay, so with this, we have, okay, okay, so multiplying in with the half, right, I will get something like this. Okay, I'll get the pi over 8 minus 1 over 4 sine pi over 2, then minus of pi over 12 minus 1 over 4 sine pi over 3. Okay, so simplify a bit more. So I will have a pi over 24 minus 1 over 4 plus root 3 over 8. Okay, then with all this, so pi over 24 plus root 3 minus 2 over 8. Okay, so technically we can stop here or we can stop here. Okay, so the bit is this, so the whole process is this. Now when we were to change the integration by substitution, right, make sure that when we change the L, the E, and the differential like this, L, E, D. Okay, and the rest is just simple trigo algebra and just some just sub in and solve and evaluate. Okay, so this will be for pop quiz number 11. Okay, so everyone, let's continue on with pop quiz number 12. Okay, so let's take a look at this question. We have an AP and GP with the same first term. The sum of their second terms is 1 over 4 and the sum of their third terms is 1 over 8. Okay, so over here, right, I'm going to put AP over here. Now, because we are thinking of the first three terms, right, so the first term will be 1 over 4. Second term will be 1 over 4 plus n minus 1d. And I will have a 1 over 4 plus n minus 1d. Okay, now at the same time our GP over here, now the first one will be 1 over 4, then afterward will be 1 over 4 times the common ratio, and after that will be 1 over 4 times the common ratio squared. Okay, so the previous one need to square. Okay, so we have D and R to consider, so let us write them out in a equation literally from the question. So they say that the sum of their second terms and the sum of their second term is 1 over 4. So this means that 1 over 4 plus 1 over 4. Second term. So this means that it will be 1 over 4 plus D plus 1 over 4R will be equals to 1 over 4. Okay, something like that. So making D the subject, okay, because these two can cancel, so making D the subject over there, so D would be equals to negative 1/4 of R. Okay, now then second equation over here would be the sum of their third terms. Okay, would be 1 over 8. So same thing, I have 1 over 4 plus 2D plus 1 over 4R squared. So this is 1 over 8. Okay, so with this, right, we managed to, okay, we will arrive something like this over here. Okay, equation 2. So what do we do now would be to sub equation 1 into equation 2 to see how do we get out from here. So this would be 2 of this. Okay, something like that. So a few steps later, we will simplify to a 2R squared minus 4R plus 1 equals to 0. So you slowly work out the math. Okay, so now this one is a quadratic equation. So what we'll do is we'll just make use of the quadratic formula. So it'll be negative b, okay, plus or minus b squared minus 4ac. Okay, so whole thing over 2a. So now let's take a look and let's see. So over here we have a 1 plus, okay, minus root 2 over 2. Okay, something like that. Okay, now, but then which one do we choose? Which one do we reject? So since the GP is convergent, this means that our R would be between negative 1 and 1. Okay, and because of this, we will reject R equals to 1 minus root 2 over 2. Sorry, we have to reject the other one because it's higher. So we have to reject the plus one. Yeah, because it will be higher than 1, so we have to reject that. Okay, and because of that, right, we are able to say that that's why R is equals to 1 minus root 2 over 2. Okay, and we can find the S of infinity over here already. So it will be A over 1 minus of this. Okay, minus the R away. Okay, so this thing will simplify to 1 over 2 root 2. And can also simplify to root 2 over 4. So there we have it. That's the answer for the question in our AP GP pop quiz. Okay, so now let's move on to pop quiz number 13, vectors 3. So let's take a look at this question. Okay, 7-mark question over here. So if a line with equation x minus a, y plus 2, and that z plus 5 over 5. And the plane P1 has another equation. the plane contains L. So I think the very first thing that we should do, right, before we do anything, is to rewrite these two equations from the Cartesian form to the vector form so that we can work them with vectors. So our equation for line L would be in the form of, okay, so x minus a over 1, y plus 2 over 1. So I think we can see that this would be our a, 2 and negative 5, plus lambda of 1, 1 and 5, where lambda is a real number. Okay, then for our plane, P1 would take the form of r dots normal vector 3, 2, negative 1 equals to 4. So this would be how do we set up this question. Okay, so in order to show that a equals to 1, we make use of the information that the plane P1 contains L1. So since line L lies in the plane P1, so this means that our a plus lambda, I think every point on L would also lie in P1. So this means that our a, 2 and negative 5 also lies in plane P1. So this means that we can just make use of the point. This point dot 3, 2, 1 will be equals to 4. So I think solving this, right, 3a plus 4 minus 5 equals to 4. So 3a would be equals to, okay, sorry, my bad, one error, negative 2 over here. So it will be 3a minus 4 minus 5. Then there's a minus 1 over here. Okay, my bad. Okay, something like this. So the 3a will be equal to 3. So because of this, a will be equals to 1. So pardon my careless mistakes. Okay, so this would be here for part 1. Okay, so let's take a look at part 2. We have a plane P2 passing through the points E with coordinate and intersects with P1 in the line L. Okay, so let's have an image over there. So for part 2 over there, right? So the image that we should have would be, we have a plane over here, right? It intersects with P1 in the line L. That means line L also lies in the plane P2. Okay, now it passes through point E. At the same time, the L also has a point and a direction, right? So technically speaking, we already have our first direction. In order to look for the equation of plane P2, we will make use of either this point or E, and we need to settle this direction over here. Okay, so I will let this point be point A over here. Okay, so let A take the form of 1, 2 and negative 5. Okay, so let's take a look. We already have one direction vector, so the second direction vector over here will be vector AE lah. Okay, so vector AE over here would be from coordinates E, so negative 2, minus 1, negative 5, minus 2, and then 8 minus 5, like that. Okay, so we have a negative 3, negative 7, and 3 over here. Oops. Okay, sorry, a few more errors. This is negative 2, so this means there will be a plus 2. So negative 5 plus 2 would be negative 3 again. Okay, and over here we have a 13. Okay, so this is my vector AE. Now, so using all this, right, so this would be my second direction vector, right? So in order to form the equation of the plane, we need a point, and then we are going to need a normal vector, correct? So the normal vector n comes from the first direction cross the second direction, right? So over here, let's take a look at how do we get d1 cross d2. So what's d1? 3, 2 and negative 1. Okay, or maybe let's look for, okay, maybe let me denote n would be like this. Okay, 3, 2, negative 1 cross negative 3, negative 3 and 13 over here. Okay, sorry, wrong one. Okay, it should be 1, 1, 5. Okay, so this direction vector over here. Okay, so the vector that I've got, you can work on this slowly. The vector that I've got is actually vector 28, negative 28, and 0, like that. Okay, so which I can rewrite further into this form over here. So I can put a 28 over here. This would be 1, negative 1, and 0. Okay, so this would be so far like this for part 2. So after this step, what we're going to do next is we're going to make use of a point and time to form the equation of a line. So form the equation of line using this form over here, scale up product form. Okay, so it will be in the form of, so plane P2 would be in the form of r dot normal vector. So the normal vector will be just the direction. So I'm going to use the 1, negative 1, 0. So this will be equals to, now I will make use of this point there. I'll make use of point E. Okay, point E. Okay, making use of point E would be to put negative 2, negative 5, and 8 dot 1, negative 1, and 0. Okay, so this would be vector OE. Okay, so with all this, right, I will have r dot 1, negative 1, and 0. On the other side, this would be equals to 3. Okay, so negative 2 plus 5 plus 8. Oh, sorry, plus 8 times 0, so it's just 3. Okay, so because of this, the Cartesian equation would be 1x minus 1y plus 0z equals to 3. Okay, so this would be for part 2. Okay, so continuing for part 3 over here, so the image that we should have would be, let's say we have a plane P1 over here, and then we have a point E right up here, and then we are going to look for the foot of perpendicular N. Okay, now take note over here, now because this is a foot of perpendicular, we are going to have this normal direction. We can borrow this to do some work. Okay, so for this, right, the concept of to find the foot of perpendicular, right, is to intersect line of EN with plane 2, plane 1. Okay, so this is the idea. Can I? So first I'm going to get line EN first. Okay, so the line through EN. Okay, so the line through EN will take the form of R equals to, now point E will be negative 2, negative 5, and 8 plus mu of the direction, and the direction vector is direction vector of plane 1. So this is actually N1. Okay, so the direction is going to be 3, 2, and negative 1, like this. Okay, so with this, right, and then just nice plane 1. Okay, so we are going to sub into plane 1. Okay, so this would be negative 2 plus 3 mu, negative 5 plus 2 mu, and 8 minus mu, like that. Okay, so this one over here, sub in the point, and then we get 3, 2, 1. So 3, 2, and negative 1. Okay, so this one is equals to 4. Okay, so slowly over here you will solve your mu to be equals to 2. Okay, and because of this, from here again, our coordinate vector, our position vector ON would be negative 2 plus 2 times 3, negative 5 plus 2 times 2, then 8 minus 2 times negative 1, like that. So our coordinate for ON, okay, or the position vector of N would be over here should be a 6. So this would be a 4, negative 1, and 6. Okay, so that will be our pop quiz number 13. Okay, so now we are in pop quiz number 14, application of integration, where we are going to look for area under graph and also the volume of revolution of a particular solid. Okay, so over here, part 1, so using the substitution, right, x equals to 2 sine theta, find the exact value of 1 to 2. integrate from 1 to 2. Okay, square root of 4 minus x squared dx. So let's write this down somewhere. Okay, so once again, when we talk about integration with substitution, we need to change three things. We need to change the expression. Okay, we need to change to the limit, and we need to change the differential. So I think let's settle the differential first. So dx d theta would have a 2 cos theta. So in pencil, I will write this as 2 cos theta d theta, like that. Okay, now then the next one over here, let's figure out our limits. So when x is equals to 1, then sine theta, right, would be equals to half. So theta would be equals to 30 degrees, right? Then when x is equals to 2, sine theta is going to be equals to 1. So this one over here will be 90 degrees, so pi over 2. Okay, so with this, right, we can change all these numbers. So 1 to 2, right? Okay, so we're going to swap the limits. Okay, so change everything one shot. 4 minus x squared. So x squared is actually 4 sine square x. Okay, now then our dx, I can replace this whole thing with 2 cos theta d theta. Okay, so all together, let me bring out this first. Okay, bringing out the 4, right? So actually it will be square root of 4 and that, right? So then square root of 4 is actually 2. Okay, and then 1 minus sine square theta dot 2 cosine theta d theta. Okay, so put both the 2's in front, I will have a 4. Okay, 1 minus sine square is actually cos square. Okay, so the square root of cos square is still cosine, but we have another cos square on the outside. So actually, I still get a cos square theta over here. Now, then making use of the double angle formula, so our cos square theta would be 4 times of this. Okay, so this would be half of over here, cos 2 theta plus 1, I suppose. Okay, d theta. Okay, so something like that. So 4.5, I'll have a 2 on the outside. And I think we can just integrate this right away already. So we have half sine 2 theta plus theta again. Okay, we have something like this. Okay, so subbing in what we have over here would get okay, so I'm going to expand with the 2 over there. So I will have sine 2 times pi over 2. So this will be pi. Sorry. Okay, sorry. So over here I have a 2 times of, half sine pi. So actually this would be 0. Okay, then plus pi over 2. Okay, minus of half times sine pi over 3. Sine pi over 3 is 60 degrees. So I have a root 3 over 2. Okay, then plus pi over 6. Okay, something like this. So I think we can simplify the whole thing to actually a 2 pi over 3 minus root 3 over 2. Okay, so something like that. So this is how we settle part 1. Okay. So part 2 over here, the diagram shows the regions R and S in the first quadrant. The region R is bounded by part of the curve, the line and the x-axis, and the region X bounded by the curve, the line and y-axis. Point P has the coordinates of 1 and 2 root 3. So we'll be making use of this point, I suppose. Okay, so find the exact area of the region R. Okay, so for region R, let's take a look. It's being made up of 2 parts. Okay, so there is this triangular part over here. At the same time, there is also this curvy part over here, the semicircle part, right? So what we need to do, right, is we need to drop down. What is this value over here? This is 1. Then this number over here is actually until 2. Okay, if we can just check. So this will be 0, right? So make x the subject, so x will be equals to 2. Okay, can so what do we do? Be from 0 to 1 of that triangle. then plus 1 to 2 of that curve. Okay, so our area for R, okay, will be half times base times height. Triangle, then plus the quadrant over there, right? So just now we've already integrated the function. So actually we see something like this. Okay, so to simplify the whole thing, at the end of the day, I will get 4 pi over 3. Okay, units square. Okay, so this is how we do part 2. Now, and in the end, let's do part 3 over here. Part 3, right, the volume of region S. Okay, so what happens is that we will take this region S over here. Right, we have this region S over here. Okay, so we have like somewhat like this kind of shape. Okay, so what's going on would be, how do we get this thing over here is that we will need to figure out what happened, right? So we have this part of the curve over here, right? But when we integrate, right, it's actually from 0 to 1 again, right? So technically it will be this whole part minus of the triangle. Okay, so it will be likely like that. Okay, and one more thing over here, the concept over here would be volume would be equals to integrate from a to b pi r square dx, or pi y square dx, like that. Okay, or pi x square dy, depending on like whether do we dx or dy. Okay, so how do we get there first? So the volume of region S. Okay, so from 0 to 1, right, of the curve. Okay, then this curve we already done in the previous question. Then I'm going to minus off the middle part. So middle part is actually a cone. Oh, actually don't need. I will just minus off the function. The function is actually 2 root 3 x squared. Okay, and then this. Okay, sorry, this one square minus that one square dx. Okay, so let's slowly we can make use of a GC to do this, because they never ask for like exact value, right? You just find the completed volume. So we can get 33.5 units square. So this one is from GC. Okay, now however, if you want to do with the integration, right, then you just do slowly, right? So it should give you a 32 over 3 pi units square. Okay, so that's all for these 4 pop quizzes. Hope it's been enriching to you. Okay, so yeah, all the best, and I'll see you in the next video to come. Okay, bye bye.